So we're going to start, I should say, just in case you don't remember my name, Mr. Gustafson, it's right up there if you can read it. Call me Mr. G if you want, that's fine. We're going to start off class today with a little problem that I'm going to pose to you guys. So for the past couple sections, you guys have been working with functions where you've been factoring them and using these factors to say some stuff about graphs. Today we're going to do it kind of backwards. So before I pose the problem, do any of you guys ever play around with your calculators, type in stuff in your y equals and see what the function looks like? Not really, no? Some people? All right, I guess I'm the weird kid. All right, anyways. What I'm going to ask you guys to do today is something like that. We're going to try to think of a function that looks something like this. So I got the idea to try to make something that looks kind of like two mountain peaks. You know, if you squint and tilt your head a little bit, you can almost see that. But anyways, you guys are going to try to come up with a function that looks kind of like this. So if you have a calculator, I think that would be the best bet. And I'm going to let you guys work on this. You can work together with anyone you want. You can work by yourself if you want. The only thing I ask is that you try. Just see if you can come up with a function that when you graph it looks something like this. So go for it. Depending on where you're at. So you guys have been working with polynomials. Can anybody tell me the degree of the function that's going to give us something that looks like that? Say that again? 4. So if you haven't found the place to start yet, start trying to work with polynomials that are degree 4. I'm talking about what we were able to come up with. So if you weren't quite able to get something that looked like this, that's okay. So everybody at least trying, which I was appreciative of. So I had mentioned that this is going to be a degree 4 polynomial. Can you guys tell me, does the graph open up or down? Down. How do we get a graph to open down algebraically? Negative where? So the leading coefficient needs to be negative. So of the ones that I saw, I thought I saw a lot of people using negatives out front, which was good. Some of the ideas that I saw, which I liked, so Tim and Lou, right? So Tim had the blue one, Lou had the red one. And my window is going to look a little awkward, so they're not going to look as nice as they did by themselves. But as you can see, the blue one had the higher hump to the right, the lower hump to the, I'm sorry, the left and the right. Lou had his with the higher to the right, but that's okay. Can anybody tell me, or either of you two or anybody else that was able to come up with something that looked kind of close, can you tell me how you went about doing it? Were you just guessing, or what were you using? So the way that you guys entered these into your calculators, what were you using? What do we call those? Parentheses. What is inside the parentheses? What is that x plus or minus a number called when we're talking about polynomials? If they divide into them with a remainder of 0. Starts with an F. Factors. So, from what I saw, one of the ways, the way that I did it, was to use factors. So, you've been using factors to divide out and find zeros of polynomials. The way I went about doing this, and how some of you did this, is you took the factors, so you kind of had to make them up yourselves, kind of put imaginary axes on the graph, and you decided what the factors would be. So instead of taking a polynomial and deconstructing it, you constructed one by taking pieces, the factors, and making them into a polynomial. So if we were to multiply both of these out, what would be the degree of these? Can anybody tell me the first term? It would be the same in both of these functions. How many x's do we have here? So we have 1 here. How many here? How many here? So if you were to imagine expanding out that whole thing, what would we get? What was the x to the what power? To the 4th. And we have the negative out front. What about this one? How many x's do we have down there? So if we were to expand this, what would we get? The first term. X to the fourth. Awesome. So, if you were able and you were just guessing, and which is perfectly fine, I think the faster way, the way that kind of relates more to what you've been doing the past couple sections, is this idea that instead of breaking down a polynomial in standard form into its factors, you can construct any polynomial you want with the zeros you want by taking these factors, which we got from looking at the graph, and multiplying them all together. So that's how those tie together. So instead of doing it algebraically and then looking at a graph like you guys have been kind of doing, you started with the graph and try to come up with an algebraic expression for it. Kind of makes sense? Any questions I can answer before I'm done? All right. Thank you guys for trying. I really appreciate it, and good luck.